All right, so for P514, the pivot, you can use the standard A landscape, or if you've created a custom uh, template, then we'll do one of the simplified from previous uh, incarnations of the template. Yeah, and I kind of like the everything across the bottom don't take up a third of the space style. So we'll go ahead into the view palette, and we can bring in our pivot assembly. Now at this point, we haven't added any of the custom properties. So when we look at the group of part numbers and links, materials just called out as steel, and 1020, 1018, those should all be pretty good. So I want to bring in, let's just go with, let's see what a trimetric looks like. Can always change these later. And the scale, that's pretty small. And I would like, oh, it's still in the dynamics. So let's go over to the default, and then we can shift to the exploded. So in the exploded, 1 to 5, that's still pretty small. So let's go down to user defined and see what third scale looks like. All right, not too bad. If we go back to the view palette, we can probably bring in, so it wants to refresh since I updated from the dynamic. And then there would have been the exploded view. So just bring in another trimetric. Now that aligned, I saw that little line go flying across there. So alignment's not really going to help me here. And we'll probably take up a little more space. So right clicking, going in to the alignment and breaking the alignment. No, I don't see it. I guess because I went through that and pushed the buttons, but we're going to look for alignment and then break the alignment to clear that out. And then we can go to tables, bill of materials. If we've created a bill of materials, then we can go select. So I made a simple at one point, and we're going to be able to see those. All right, so nothing's really jumping up here. And notice that the hex bolts and the pins and the other items will still show up in there. All right, so one of the things that we discovered that was added was the pictures. So those are pretty handy to be able to go through. But what I really want to do with this is on the first pass, we're just kind of getting everything set up and see what I need. So I'll need to add the part numbers, the material, all of that stuff. Let's go ahead and we'll start picking out our views. And whatever way you're most comfortable with setting these up, but I like to go through and set the views and figure out what it is I need, and then come back after the fact and start to do the dimensions. So, oh, that one must have been stuck in the sheet view before I changed it. So that one went to parent scale. Now let's just switch it over to the sheet scale. So it looks pretty good. And we're just going to go right down the line to the next would be the handle. Oh, the post handle or the post link, doesn't really matter. So let's go with a front view, and then notice the right mouse button has the check mark. That would go ahead and complete it. So those look pretty good. And then I'm just going to stay with the view palette and the post link. So this one had the front and the top, and then last will be the handle or the knob. All right, so since the pins, oh, and I missed that one, so let's go back into the drawing, find a projected view. I'll slide that one in over there. All right, so since, well, this would be a good one, since I'm just kind of thinking out loud here, let's go ahead and make that one hidden. There isn't really anything hidden there. Okay, so once we've made the passes, we've got the views. Think I've got everything I need. Then we'll start going through on the next pass and putting in the dimensions. So I would like to load everything to the left side, and that doesn't look too busy, but busy enough. And we have the assembly. All right, so that didn't get center marks, so we'll see if the slots come up. The slot need to go into the default. So one of the things that I would like to do is add the colors and the center marks for the slots, since those are coming up quite often. We'll go ahead and accept that. So I should be able now to go point to point, and since I'm in inches, I'm going to see the metric conversions. Well, that one seems to just keep, sometimes they get in the way. So as far as just getting the dimensions in, that's kind of the immediate trick, and then we'll come back and see how we would like to line these up. So if I select the two edges and go to a center line, well, let's just go to the view. Sometimes it'll take the two edges, and then we'll stretch the center line out a little bit. And depending on what we decide for manufacturing on this piece, the geometry may come in that we would bend this, have a forming tool, and then weld it onto the face. So we would have to make those choices. But at 5 millimeters, that's a pretty thick piece of material. So I would think that I would want to try to control the overall, and then come back from there. So, and again, it's just a process of getting the geometry in, and then we'll start looking at what we're going to do for tolerances. So the way that they ran this one was kind of a baseline. So I'm not 100% sure. Probably would turn this on the lathe back to this point, and then use the mill to, oh, not in the smart dimension. So let's make that the datum is wherever that geometry comes up, and then if we have to chain, we're going to chain off of that geometry. So since the pivot is probably more critical than the overall length for the handle, really that geometry is what I'm going to start with to control. All right, and all of these were put in with the cut extrudes, so it's not like I'm going to get the instance count with it. So we'll have to control the instance count. All right, so those look pretty good. And we'll get back into the smart dimension. And we need we did the radius, now we need the diameter. And that should be, that was the overall. So one of these is going to end up being a reference dimension. Since we have the distance and then the pivot, I think that I would like that to be the reference. So if I go to the in-place dimension control, we can hit the parentheses, which is the same as coming over here and telling it the dimension text is on the parentheses. All right, so we need a length. So we have the radius, the diameter. Let's see, we're going to need the fillet. And probably going to need another center line. So based on the geometry, what is critical here, we did the radius. Problems with the radius is if we look at the stack up of the tolerance, we're giving this width more tolerance if we drive from the radius. So as we think through that process, it's probably not very critical on the width. Oh, yeah, that wasn't quite the center line I was looking for, so maybe we'll see if I can undo that. So it did the center lines through the whole locations. All right, let's just X out of that. And what I really need is for one going that way. And since it's not giving me that one, we'll go into the sketch and I can force a center line that way. All right, I would like it to where that is not able to move. So just like in the sketches, if I can select the midpoint, then I can force it to be coincident, but I want that extension to go almost and create a little bit of a gap. All right, so what that gives me the ability to do then is we can dimension one side, dimension, yeah, now it's gonna tell me about driven dimensions, which is fine because it's already being controlled. And then that becomes the 7 millimeters. And if we drive the overall at 9 millimeters or 14 millimeters, then we can kind of make that determination which side is going to more critical. So do one, and I think we'd probably do a reference dimension again for that side because, well, I still need to do the stack up, but what is going to control this or what is more critical is the slot width and the overall. And if this changes position, then this number would be the one that I would want to shift. All right, so as I say, those don't look too bad. And we'll come over and do this side. All right, so we have a 30 millimeter. Now that one didn't get a center mark. So we'll place it and we can go smart dimension to there. And then our distance. For the whole wizard, since I used it for the drill point, it's going to give me the 472 by 472, 12 millimeters diameter, 12 millimeters in. So that will work. And then we go back to the beginning. We're at the part number stage. Again, my graphics card kind of leaves those ghost images, so quick Control Q. This is a little messy, so on the next pass when I'm doing the tolerances, would look at adjusting those. And then as far as the spacing, we have a little more room that way. All right, so I'm ready for some part numbers. At some point I am going to want to save this. So it can be the same name as the assembly. All right, so I'm going to refer back to my chart, and when I open the pivot, we've set up the custom properties, and this is going to be the ENG A43, revision A. Material is, well, they have SAE, we have AISI. Now this was done in millimeters grams, but if the drawing template is in pounds, then we haven't set that as a custom. And I'll put my drawn by and my drawn date and apply those. Okay, so we make sure to save that, and when I close it, then I should see those update, and I can start to do a little bit more with the spacing on the chart. All right, so one by one, we're going to go through each of these items, and this one is the handle. So A44, revision A, we'll stay with 1020. I'm going to go with the gram, put the date in, apply, and this just becomes a little bit easier to go through like all at once, or feels easier to go through all at once to generate my metadata for the documentation. So A45 and the steel. Now the pins and the other bolts, nuts, screws should all have in their description or their style already have that information. So, and then the handle becomes the, well, shifted to AM300-1. And it's just steel, but since we made everything else out of steel, we will stay with that as a as our standard. All right, so I got my dates, got my timestamps, and that goes as well. So no real part number. If we looked up from our supplier, let's go ahead and save all. If I looked up from my supplier, I could override this and put in a supplier name, but anything that I do manually, I'm responsible for managing and updating and making sure that the information is correct. All right, so what I didn't do in here, what I would like to do then is, I'm not sure if I can, well, let's try it. We'll go with the alternate position, view, and drawing. And it's setting a new configuration. It opens up the assembly, and then it should allow me. So that one's saying it's fully defined. It's not allowing me to change configurations just yet. So what I might want to do, let's see, did it actually create one? Probably not. Is on that one I would shift it over to my dynamic view, and I can't say that I expected it to do that, but that's pretty good. All right, so the dynamic view is subject to whatever position that I left it in. So I might want to check that configuration and make the angle to where it goes over a little bit more, but at least that has enough information in it to show how you want. Now these aren't 100% necessary. You're always doing the, uh, does it add value to the drawing? Is it something that is useful? So as you make those determinations and we go through the process, then we can do a little bit more with that geometry. All right, so the one thing I would be interested in here is the 787 is not critical. So the next pass would be to add tolerances. And I just want to tolerance a couple of these so you get a sense of the process. Let's see, we're going to go from 3 decimal places to 2. That gives it a wider range. Doesn't really affect anything. But because this is going to be a press fit, and I'm gonna be thinking in terms of fits. I would like. That's still going to be a pretty hard fit, and I don't have a lead on that. So let's go ahead with a bilateral, which will give it a plus dimension. I would like to have about 1,000th plus fit. I don't want to increase the cost of this, so I'm going to go +1 minus nothing, which is not a terrible tolerance to hold. And that's going to make it a little bit bigger. And when we come over to the handle on this side, we can pick the diameter and the depth. The depth is not real critical. We might move it to 2 decimal places to be generous. But on the diameter, I would also want to do a bilateral, and it would be a minus 0.001 for the fit. So 2,000ths. I mean, at best, this ends up 472, and the other one ends up 472. It's a transitional fit. There's barely any press there, but at least it wouldn't be flopping around. Worst case at a 2,000ths, we would need a little bit of force to jam these two pieces together and make those work. So, but we want to start thinking about that process. Now, what we don't have in here is, since this is going to rotate, do we need a bushing? How much load and force is this actuating that we might want to make this a little bit bigger, press a bushing in, and have a bronze bushing right on a steel or a stainless steel on the stainless steel pin? Is this also a press fit? Is this going to be able to slide back and forth? There's a few things that, because of the fits and clearances and the movements and motion, that we have lots of clearance, but we have to determine what exactly it is that we want to allow to move. All right, so I think the drawing is pretty good. We'll go ahead and rebuild and save. And this gives us our list of components. So I can do a little more cleanup. Anywhere that there's 2 or more, I could put in the typical, but if we have a count or it's a low count, we'll put in the actual quantity. So on the whole size, probably the same thing. And just try to catch as much of that as possible so that when it comes up for review, it is not a situation where you're having to go back through and change a lot of stuff. All right, so again, wherever I'm making these modifications, if I'd use the whole wizard, it would give me an instance count, but it's not always always the fastest, or wouldn't think about it being the best route. All right, so that one we would kind of assume through all. but just to be on the safe side, we could add a through. And if we did add in the hidden line shown, does it add enough detail there to show that it's through? I mean, those are kind of the questions. Error on the side of it makes more sense, or um, will fill in the blanks.